today we're going to talk about notation. So our objectives today is going to be convert numbers between standard and scientific notation, and then also to find products, powers, quotients, sums, and differences of numbers that are in scientific notation. Okay, so the first thing we want to talk about, well, what is scientific notation, right? So what is the definition of scientific notation? It is a number expressed as a product. So remember, product means to multiply, right? So as a product in the form A, so A is a number, times 10 to the nth power. So here's something very, very specific about A. A has to be between the numbers 1, but it has to be less than 10. Okay? It's very specific about A. Okay? So how does it work? How do we work? So let's say we have this really, really big number. We're going to get the number 4,200,000. And we want to write that in scientific notation. How do we do that? Well, remember, A has to be less than 10. So we have to move our decimal place. So our decimal place is currently right here. So we have to keep moving it until we have a number that is less than 10. Okay? So we move it once. Okay? Our number is still not less than 10. We move it again, still not less than 10. Move it again, we're still not less than 10. Move it again, we're at 420, we're getting close. Move it again, 42, not quite there yet. Move it one more time, and then we'll have the number 4.2. Now 4.2, that is a number less than 10. So our A is going to be 4.2. Okay, now all we have to figure out, well, what is the n? Okay, to figure out the n, well, how many places did you have to move your decimal? 1, 2, 3, 4, 5, 6. We had to move it 6 times. So the n is 6, okay, but one more thing. Is it positive 6 or negative 6? Well, if it was positive 6, that means that this number is really big. Okay. If it was negative 6, that means this number is really small. Well, since our original number was really big, it's positive 6. So our answer is 4.2 times 10 to the 6th power. Okay. So let's try another one. Let's try the number 0.00067. Okay, so it's a large number. Okay, so again, the first thing we want to do is we want to move our decimal until we have a number between 1 and 10. So let's see, we move it once, still too small. Move it again, still too small. Again, still too small. Again, we're at 0.67, which is, that's still less than 1, so we have to move it one more time to get 6.7 for our A value. Now all we have to do is decide what's going to be our exponent. Well, how many times did we move our decimal? 1, 2, 3, 4, 5. So our exponent is 5. However, this is 6.7. Was our original number smaller than 6.7 or bigger than 6.7? It was smaller, so that means our exponent is negative 5. All right, so let's go ahead and do example 1, now that we've talked about it. So when we do example 1, I would like you to go ahead and try it yourself and see if you can come up with it. So example 1, part A, I want you to do 29,500, and you are going to put in scientific notation. So go ahead and pause the video and see if you can figure out how to do it. All right, so first thing first is we move our decimal. We have to locate our decimal. Since this is a whole number, our decimal is at the very end. So we have to move it until we get a number between 1 and 10. So 1, 2, 3, 4. I moved my decimal 4 times, which means I have an exponent of 4. So the question is 29,500, is that smaller than 2.9 or bigger than 2.9? Since it's bigger than 2.9, our exponent is positive, which means our answer is 2.9 times 10 to the 4th. So one little thing, we did not quite do this right because we forgot our 5. So this should be 2.95. I'm sorry, 2.95 times 10 to the 4th. There we go. All right, so let's try another one for example B. For example 1. So example 1 part B is 0. Let me see how many zeros there are. 1, 2, 3, 7 zeros. 2, 3, 4, 5, 6, 7, and then a 4 and a 3. So go ahead and pause the video and see if you can figure this one out. Okay, so first thing you do is you move your decimal until you get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8. So you get your A value of 4.3. And since we moved it 8 times, that's the exponent. So now you decide positive or negative. Is this number 0.00000043? Is it smaller or bigger than 4.3? Well, it's smaller, which means our exponent is negative. All right, so in order to convert from scientific notation into standard notation, that's easy. You just go backwards. You take whatever your exponent is and you move the decimal. So remember, if it's positive, you want your decimal to go bigger, and if it's negative, you want your number to get smaller. So that's all you're doing to go from scientific notation to standard notation. So let's try example 2, and I'm going to do these with you. Example 2. And so for example 2, we're going to standard notation. Okay, so for part A, we have 2.1 times 10 to the 5th. All right, so in order to go to standard notation, we take our decimal on 2.1, so we're going to take that decimal, and we're going to move it 5 times. But since its exponent is positive, we want our number to get bigger. So that means that we're going to move it to the right, so that way our number gets bigger. 1, 2, 3, 4, 5. New decimal place, okay? So what happens is that these gaps right here become zeros. So we have 2, 1, and then we have 4 zeros, which means that we have the number 210,000 as our final answer. Okay, so let's do part B for example 2. In this one we have 6.8 times 10 to the negative 6. So again, we take our decimal and we're going to move it 6 times. So since it's a negative exponent, we want 6.8 to become a smaller number. So we're going to move it to the left. 1, 2, 3, 4, 5, 6. So remember, all of those gaps become 0. So we get 1, 2, 3, 4 zeros. 1, 2, 3, 4, and then 6, 8. That is our final answer for part B. All right, so now that we had a refresher on scientific notation, which you might have used in science before, we're going to talk about, well, how do we do operations? We're going to use the commutative, associative, and distributive properties to help us calculate products, powers, quotients, the most important thing is that when we finish and we get an answer, we had to make sure that it's still in scientific notation. So let's do some examples. This is example 3, and example 3 has 3 parts. So part A, we have 7.5 times 10 to the negative 5. And then we have 2 times 10 to the third. So notice this is a times, and this is a times, and this is a time. There's no adding or subtracting. So since everything is being multiplied, we can use the commutative and associative property to rearrange things, right? I can rearrange this to say 7.5 times 2 and 10 to the negative 5th times 10 to the third. Well, 7.5 times 2, that's 15. And then I have 10 to the negative 5 times 10 to the third. Well, I have the same bases. That means I add the exponents. So 10 to the negative 5 plus 3. Well, 10 to the negative 5 plus 3 is 10 to the negative 2. Okay, 10 to the negative 2. However, I am still not done because this is not in scientific notation. This is a 15. Remember, your A value has to be between 1 and 10. 15 is not between 1 and 10, which means I have to change it. So 15, I have to move the decimal. So it'll become 1.5 times 10 to the, I moved the decimal once, but I moved it so that way it could be smaller. So it's going to be negative 1. So 10 to the negative 1. And then I still have this times 10 to the negative 2. So again, I have bases that are the same. So now I have 1.5 times 10 to the negative 1 minus 2. I'm sorry, this should be 10 to the positive 1, right? Because 1.5 was smaller than 15. Oh, sorry. So this is positive 1. So positive 1 minus 2 becomes 10 to the negative 1. There we go. There's our final answer. Okay, let's look at B, okay? So part B, for example 3, is 1.2 times 10 to the negative 4 squared. Okay, well that squared means to multiply by itself, right? So also you could say, well, that's the distributive, right? That's a power of a power. So we're going to distribute that power, right? So we got distribute the power of the 2. So we've got 1.2 to the power of the 2 times 10 to the negative 4 to the power of 2. Okay, well 1.2 squared, that's the same as saying 1.2 times 1.2. We can do the math on that.